Thank you for joining us today on this webinar. My name is Ashish Kurmi, and I'm a co-founder and CTO of StepSecurity. Varun Sharma, my co-founder and CEO, is also on the call. So this is a community call, and the idea is to learn from each other. So, we are planning to go through this blog post and share what we know about this attack. And a few housekeeping things. So if you have any questions, feel free to drop them in the chat area. Towards the end, we will also have a dedicated Q&A. But in the meantime, we'll try to answer your questions in an async manner if possible. So let's get straight into it. So on March 30th, we detected a supply chain attack on Axios. And for those who may not know, Axios is the most popular JavaScript HTTP library. So, look at this download count. It's being downloaded at about, it gets downloaded, more than 100 million times every week. And this package is everywhere. It's in your front-end apps, it's in your back-end services, it's in your CI/CD pipelines. So after we detected this incident, we created this GitHub issue in the repository. And thanks to the community, it was resolved quickly. The community jumped in fast. NPM maintainers, NPM and GitHub, took the required actions. Maintainers jumped in fast, and the incident was mitigated in about 3 hours. But these 3 hours were enough, because if you ran npm install during that window and pulled in one of these compromised dependencies, a remote access Trojan or rat was dropped on your machine, and your machine was compromised. And this exploit is quite versatile, as it works across a variety of operating systems such as Mac OS, Windows, Linux, and other variants of Linux as well. So let me walk you through, let's go back and let me walk you through this attack. So here's the first thing, we notice, which is there are 0 lines of malicious code inside the Axios package itself, 0. And because the attacker did not change a single line of source code, instead both poison releases had a fake dependency, plain crypto.js. So this plain crypto.js package was added as a dependency, but it was never imported anywhere in the source code. And its sole purpose was to run a post-install script that deploys a cross-platform, rat, which compromises the machine. And then after that, it would clean itself up, leaving no trace behind. And again, this was not some random script kiddie. This was well planned. The malicious dependency, which is this plain crypto.js, was staged 18 hours in advance, and this was done to ensure that this malicious dependency had release history. And this remote access Trojan payload was built for all 3 major operating systems, and both release branches were compromised within a short window of 39 minutes. So this compromise was detected by StepSecurity AI package analyst, which is our platform feature that analyzes open source packages the way a senior security engineer would. And this package was analyzed the moment it was released, and it detected that it was compromised. So this was one feature we used to detect this compromise. The other signal that we used was it came from StepSecurity Hardened Runner. So StepSecurity Hardened Runner is a purpose-built security agent for CI/CD runners, and you can think of it like an EDR for CI/CD. And StepSecurity Hardened Runner is free for open source projects. So its community tier is free for open source projects. And for example, over here you see that backstage, when it tried to use the compromise package, it made an outbound call to this C2 domain, which got flagged as anomalous because this domain wasn't observed, in this job. And backstage has confirmed that they were not impacted because this was this ran in an isolated environment. But it shows how hardened runner detected this supply chain attack. So now let me walk you through the attack timeline. So first on, and again these timestamps are in UTC. So the first event happened on March 30th at about 6 a.m. when the first release of plain crypto JS uh, was made available on npm JS. This is a clean decoy, and this was an exact replica of the real crypto.js library. So no malicious code was added in this release, and the purpose was to build publishing history. So the account does not look brand new. Then about 18 hours later, uh, the next version was published, which is 4.2.1, and this version was malicious. This version had the malicious payload. A post install script was essentially added, which was a dropper script, which I'll cover later. Then 21 minutes after midnight, Axios 1.14.1 went live, and it was published by the compromised maintainer account. This is the lead maintainer account. This is the lead um, maintainer of Axios. And then 39 minutes later, Axios 0.30.4 was compromised using the same approach. And this is the legacy branch. So, the attacker compromised one dot series as well as the legacy branch. And then at about 3:15 a.m., npm unpublished both versions. And at 4:26, npm places a security hold on plain crypto JS library, which was the malicious dependency that was added in both compromised versions. So now, we can look at how the attack worked, and the sequence of events that led to this compromise. So step one, the attacker compromised the npm account of a lead maintainer of Axios, and in this case, the attacker actually compromised both the npm account as well as the GitHub account. The attackers changed the registered email address to this proton.me email address. And here is a key forensic detail. So every legitimate Axios release is published through GitHub action with npm's OIDC trusted publisher mechanism. So that means the published version is cryptographically tied to a workflow. So if you go back to the npm JS page, and if you go back to versions, you see all these green ticks next to these versions. And if you click here, so it says that built and signed with provenance. So this means npm JS could verify that those releases came from this particular GitHub Actions workflow job, and it used OIDC for publishing those versions, whereas these compromised versions actually broke that pattern. So no OIDC binding was used to publish these compromised versions, because the attacker directly published these compromised versions on npm. So they essentially stole a long-lived npm access token and used that for publishing these compromised versions. So yeah, so step one, they actually stole a maintainer's GitHub and npm account. Step two is where they published the fake dependency, plain crypto.js 4.2.1 using this account. And you can actually see the difference between the decoy version 4.2.0, which was the first release, and the compromised version 4.2.1, which actually had the malicious payload. So in the malicious payload, package.json had a post-install script. Setup.js, was added, which was getting executed as part of this post-install script. And this malicious version also had package.md, which was a clean JSON stub, which actually reported the compromised version as 4.2.0 and not 4.2.1. And again, I'll cover, like how this package.md was used to basically, make it difficult for incident responders to, detect this compromise. Next, we can look at the injection. So I've actually covered these things. So, yeah, so we can look at the actual injection into the Axios project. So, step 3, after publishing the compromise, after publishing the malicious fake dependency, the attackers added the the plain crypto.js library as a dependency for Axios in these two versions. And you can easily see that when you compare the compromised version with the previous version. So the previous version, which is uncompromised, 1.14.0, has these dependencies in package.json. So follow redirects, form data, proxy from env. But the compromised version, added an additional dependency, which is plain crypto.js. And similarly, the legacy series again had the same dependencies, and even in the legacy series, plain crypto.js was added as a new dependency. And if you actually compare the compromised version with the uncompromised version, and if you do, like a binary diff between these two versions, you would see that only one file was changed. So, compromised version was exactly same as the previous version. The file that was modified was package.json, where which you can see here. So the version was upgraded, and this plain crypto.js was added as a dependency. All other files, 86 files basically remained the same. No other changes were added. So next, we can look at this rat dropper script, setup.js. So when this compromised Axios package was installed using, let's say, npm install, it executed the post install script, which in turn executed setup.js. So setup.js, is a single minified JavaScript file, which used, obfuscation scheme to basically try to evade, detection. So all the strings, in this file, module names, URLs, file paths, shell commands, were stored in an encoded array. And, two functions basically decoded this encoded array at runtime using XOR and base64 operations. And we have decoded every string, and then, you can see all the decoded strings here. And using that, we were able to reconstruct the function, which we have covered here. But, we can actually see it's working through this flow chart. So when the developer, installs the compromised version, it actually executes setup.js from, plain crypto.js. And then when setup.js was executed, it basically decodes the payload. And then it makes a call to this C2 domain, which is sfrclak.com on port 8000. And then depending upon the platform, this C2 domain was returning the actual remote access Trojan or rat, which, I'll cover shortly. So this is the, fully decoded setup.js. And as you can see, this is the C2 domain, C2 URL. It had a unique campaign ID. Then, it was figuring out the platform, and this was used to basically download the appropriate rat, from this C2 server. And then it has now then it has these platform specific code sections, which I'll cover shortly. So this is for Mac OS, this is for Windows, and there is this else branch which covers Linux and all other variants of Linux. So let's look at platform specific codes of on Mac OS. It was writing an Apple script at this location, and then it was executing this Apple script. This Apple script was making a call to the C2 domain with this unique post body. So you will see that for all platforms, it was using this unique um identifier. So for Mac OS, it was product zero, and then it downloaded the Mac OS RAD binary, saved it at this location, executed, and then it executed it via shell, and then the script deleted itself. On Windows, first it copied PowerShell to this location to disguise PowerShell as Windows terminal. Then it wrote a VB script to a temp directory and executed this VB script. And the VB script basically ran curl to fetch the rat for Windows. And on Linux, it was pretty straightforward. It was just doing this curl call, and it was again passing this unique product ID. So for Linux, it was product ID was product two, and then this was actually storing this Python script at this location, and then it basically executed that Python script. So next, we can cover this part, where it was trying to like hide itself. So like I mentioned, after executing setup.js and executing the corresponding rat, the script deleted itself, and then and then it also deleted this package.json file, and then it renamed package.md to package.json, which was reporting the version as 4.2.0 and not 4.2.1. So you cannot really rely on the version of the package to figure out whether you are impacted or not. The most definitive way to detect whether a machine is compromised or not is to look at node modules and look whether this plain crypto.js package is present or not. And if it is present, then that means that machine is compromised, because this is not a legitimate package, and this package was exclusively used in this supply chain attack. So everything I described was from static analysis, and let me show you what happened at runtime. And for this analysis, we used StepSecurity hardened runner. And earlier I shared this insights page for Backstage. So StepSecurity offers a community tier which is free for open source, and by design insights for community tier are also public, so that anyone can view it without requiring a login. But let me show you what happens when we install this package using our enterprise tier to actually look at more details. So the first one is, you see, when this package was installed, it was installed at 1:30:49, and then after 2 seconds we see the first call to the C2 domain. So this is and then after 36 minutes we see another call, which is from a different step altogether. So as you can see, npm install step had completed, and this call happened after 36 seconds. So the npm install step had finished, but the malware persisted on the machine. It was running as a detached background process, and this is why you see these calls marked as infrastructure events, because our platform could not map it back to a GitHub action step. And if you look at the process event for the first one, so you see that. So this is where it's downloading the rat. So this actually ran on a GitHub hosted Ubuntu runner, and that's why you see this Python script is getting downloaded. Another quick thing I can show you is the file override operation, right, where I mentioned after the script was executed, it was overriding package.json, and you can see that in action here. So over here you see that after npm install step was completed, which executed setup.js, package.json was overwritten to basically show the incorrect version. So let me go back and let me quickly cover indicators of compromise. So, we have published uh, compromise package checksums that you can find here. The main, I would say, the primary indicator of compromise in this case is the call to C2 domain or the C2 IP. And then we have also shared, some file artifacts that you can look for. So next, I can hand this presentation over to Varun, who will cover how to discover whether you are impacted and the recovery steps to follow.
Yeah, I think just go ahead and share my screen. So in terms of am I affected, we will look at it from three different environments. We look at it from the code repository and then CI/CD pipelines and then developer machines. So for the code repository, if it might have happened that you ended up adding this package in the repository, and that could have happened either because during that time someone pushed a commit with these versions, or maybe Dependabot upgraded or RenovateBot upgraded the package to one of these compromised versions. And we have seen those kind of cases where Dependabot or RenovateBot updated it, and that could have also caused the CI/CD pipelines to run. So these are some search, so GitHub search queries that you can use. What I can do is I can show one of the projects, just like a public repository. And I've just taken this as an example. There's nothing, special about it, just to show what this would look like if you had these packages in the log file. So here in the log file, we can see that the axios package, the compromised one is present here, 1.14.1. And the other one, which is this plain crypto.js, this is also present. So, during that time, this repository ended up adding those compromised packages. And, this is what it would look like, if you were to do that search and if you were to find it in your repository. Now, in terms of doing, um, a search for these packages, if you want to do that locally, you can use npm list command, or you can parse the package log.json file. And like Ashish mentioned, this one, is a pretty good indicator if you have the node modules uh, slash plain crypto.js, because this package was only created for this incident. Now, moving on to CI/CD pipelines, the next thing is to look for pipelines that ran with these uh, compromised packages. And before I kind of cover that, I did notice, that there was a question around pinning of GitHub Actions, and if that could have prevented this. So, that wouldn't prevent this, right? Because this is not necessarily coming in through a GitHub action. So if you had, for example, as part of your uh, project, if you were doing npm install in your CI, and you don't have a package log file, you have a package.json, and that can then pull in the latest version. And similarly, if you have some other build tools that you install and they pick up the latest version of Axios, then it can get installed. So just because you have, you know, pinned your GitHub actions, that would not necessarily help here because this is doing an npm install, which can be, which can be done outside of a GitHub action. In fact, we have also had some reports where certain GitHub actions were just pulling in the latest version. So even if you pin the GitHub action, it does not necessarily mean it's not going to pull the latest version of a package when it runs. So now looking at how can you know if you're impacted on the pipeline? So there are these couple of ways, right? So one is the build log, but again, this is not like a foolproof method. If the build log is missing, this doesn't mean that it did not install it. But if it is present, then it did. So if you do find instances of uh, these packages with these versions mentioned in the build log, then the CI run did execute them, and we have seen such build logs where you could spot it through the build log. Uh, and then in terms of the network egress traffic, if you do have monitoring on your CI/CD runners, then you can look for these uh, domain, this domain or this IP address to see if a call was made, and if you can then correlate it back to your runner. Now, if you are able to find that, it did run on the runner, then if it is a persistent runner, then you must assume that it is compromised and, you should just rebuild it. Uh, and if it is a ephemeral runner, then, it only runs a single job. And so the machine doesn't really have to be, you don't have to do anything about that ephemeral VM. But in both the cases, the credentials that were available to that uh, to that CI/CD pipeline should be assumed to be compromised and should be rotated. In fact, for persistent runners, a lot of times they just get access to more credentials. So that, in that case, you need to figure out what all credentials did that uh, persistent runner have access to, which might have been on the runner at that time, and then rotate them. So that was about the CI/CD pipelines. And before I go forward, Ashish, were there any questions related to these two things that we can cover right now?
Um, so there was a question about pinning which you have already covered. I think we can continue and we can cover all the questions, at the end.
Okay. So in terms of so we looked at the code repository, then we looked at the CI/CD pipelines, and now the third one is the developer machines. And now let's say you want to figure out whether any of the developer machines were compromised. Again, you can check for the malicious npm packages, and this plain crypto.js is a good way to figure this out. You can recursively find the node modules folders in the home directory, or whichever directory you think the packages would be in, and look for this package. Now, for this, we have this open source project. It's called StepSecurity Dev Machine Guard, and this does a bunch of things, like it lists down your IDE extensions and coding agents and MCP servers, but it also lists down all the different npm packages that you have on your machine. And so this is also something that you can use to do the same thing, to try to list down all the packages and then find if the compromised packages are there on your machine. Um, Now, in terms of the uh, what this rat was doing, and if you have an EDR solution, something like CrowdStrike, then you can use that to figure out which machines were compromised. And a lot of these EDR solutions have created their own support pages specifically for this incident. And so, you can refer to those. But here are some of these indicators of compromise, and these are separate for each of these different operating systems. And then once you find that a machine has been compromised, I think I'll cover what to do about that in the recovery steps. But this is just to figure out which machine was compromised. And then similar to the EDR solution, if you also have some sort of corporate proxy uh, outbound firewall, then you can look for these IOC domains again to find which developer machine has been compromised. So now we can move towards the recovery steps, right? So here, let's say you have found some code repository which has these uh, packages installed, then the next step is to uh, clean it up, right? In fact, you also need to look at if you ended up releasing the uh, building and releasing it to some artifact registry or some cloud deployment, and then the impact is obviously much higher. Uh, but let's say you have found it in a repository, let's say Dependabot merged it, or during that time a developer pushed it, then you can downgrade it to a known safe version, and you typically, I think, not have the node modules folder in your repository, but if you do, you can you know clean that up. We did discuss a bit about the pipeline. So here now, let's say again you have found the that some pipeline did run these packages or did install these packages. Then you need to um, rotate those credentials. So you have to figure out which credentials were available to that pipeline and rotate them. I think there was a mention of this ignore scripts in CI/CD, and which is the best practice. What we have seen is that practically speaking, there are certain popular packages that do use post-install hooks, and so that can sometimes make this hard to do, but it all depends on whether you are using those packages or not. Then in terms of developer machine, so let's say you have found a particular machine is impacted, then uh, you should just assume that it is fully compromised. You need to isolate it and then uh, rebuild it. But before you do that, just create an inventory of what secrets it had access to so that you can, rotate them. Also, as a precautionary measure, you can add uh, these IOC domain and IP address to a block list if you can do that. We did see that a lot of times these domains end up being reused in future compromises. So that can just help for future issues. Now, in terms of some of these defense in depth uh, measures that you can take, so these cooldown checks, cooldown policies are a great way to prevent impact from these kind of compromises. And what this cooldown means is that there are features that you can enable where the if a package has been very recently released, let's say within the last day, or and you can set that in the policy, 2 days or 7 days, then you don't use it. And the reason it helps is because most of the times these compromises get detected within the first few hours and within the first day. And if you have this kind of a cool down policy in place, then it will not impact you. So here is an example of how you can set it up in Dependabot. So Dependabot doesn't end up creating pull requests for something which is just recently released. And then, NPM and various package managers in the NPM ecosystem have more recently enabled these kind of features. Like, there's this min release age for NPM, and PNPM has minimum release age, and Yarn has, and Bun has, and these are newer features. So if you're using like previous versions of the package managers, they will not work. But this is definitely a good area to start looking into cooldown policies to help prevent the impact of these kind of compromises. I mean, you may not be able to prevent an upstream package from getting compromised, but you can, prevent it from being used in your environment. So that was kind of, the am I affected? And for the community tier, Ashish, was there something that I missed that you want to cover?
I think you covered it all.
Okay. So, since a lot of our enterprise customers have also joined this webinar, I can also walk through um, the steps for our enterprise customers. And overall, a lot of the things we discussed would be the same, but our platform just helps with a lot of these things through automation. So just give me a second. Let me bring up the. Yeah, so this is what our dashboard looks like. And, here we are using a demo organization. And the first thing, to mention is the threat center uh, alerts. So you would have gotten a threat center alert for this within the first few hours, and it's ideal to sort of integrate this with a pager duty kind of solution so that you can become aware of these incidents quickly. And then if I was to click on this particular threat center alert, it also has this am I affected section, which can then help you understand if you were uh, impacted. And so here, the first thing we can look at is the hardened runner insights, right? So if you are using hardened runner, which is our EDR for purpose built for CI/CD runners, then all the outbound calls that are made during the runs, they are recorded and you can search them later on. So in here, we can look at this uh, baseline across the org. And here we can see that we see the IOC domain. And clicking on the view workflow runs, you can then look at what GitHub Actions workflow runs made that call. So in here, I can click on this one, and this is the same one that Ashish had walked through earlier. So with this, you can basically know, if any of the CI/CD runs have made that call to the IOC domain, and if so, which are the particular workflow runs. And the reason that helps is because then you can figure out what was the workflow and what secrets does that workflow have access to. So then you know what to rotate. Now, in here, I can, just show how this is added. So um, this is a GitHub hosted runner, and one of the ways to add it is through an action, the hardener action. You can also build it into a custom VM image. And this analysis we had actually done, we have this repository where we analyze these compromised packages. We had done it while the package was live. So you can see here it does an npm install of the compromised version, and then we are observing it here. Um, so I think Ashish covered a bit about this, the IOCs that we observed in this. So I'll not go into that. But the other thing I want to mention is that if you had set up a block policy, which you can do through hardened runner, then these outbound calls would have been blocked. So in here, I don't have an example for this particular package, but I can show an example from a previous compromise of this particular action. And here you can see that um, you know the hardened runner has been configured with a block policy, and these policies you can create based on the baseline. And so here you can see, because it was not in the allowed list, this outbound call has been blocked. So in cases where the block policy was set, that even for the Axios package, the call to the attacker domain would have been blocked. Let me go back here. So we have covered hardened runner so far. And then let me see if I can go back to the threat center. So next we can look at the NPM search functionality. And like for the earlier I had mentioned that you can search, you have to search for these packages, whether they are used in any repository or developer machine. Now you can do that through our dashboard and also through API. So in here you can see that you can search for these packages. In fact, with this you can search for any uh, npm package across different GitHub orgs and also across developer machines, all with a single search. And so in here we can see that this package was added in a pull request, and it was also installed on a developer machine. And here it says inactive because it becomes inactive if since then you have cleaned it up. But this is just a demo, environment where we're showing that this is how it would look like if it was installed on the developer machine. And this is, so here we show it across the pull request, default branches, and developer machines. And so if it was in a default branch, it would also show there, and this would show a default branch. But this is a way where you can, quickly find if there was exposure across pull requests, default branches, and developer machines. Now, in terms of the developer machine, I can just quickly cover that because I had spoken about that dev machine guard. So in this case, you can deploy that same script uh, through your existing MDM solution, and then the results become available in our dashboard. So the same NPM package search is also available here, but that script also can show you what ID extensions you have, what AI agents you have, what MCP servers you have, and this installation script is the same, which is the Dev Machine Guard open source script that I had shown. Okay, so we have now covered the hardened runner and the npm search and the developer machine. So now I can talk a bit, in terms of some of these preventive controls. So we had discussed about the cooldown checks, right? So uh, for this one, one of the capabilities we have is to configure GitHub checks, and you can configure a cooldown period, and this is for pull requests. And you can set up in settings how what should the period be in terms of days. So in here we can see an example, uh, and so there's both checks for cooldown as well as compromised packages. And in here we can see this example where this package was added, and this required check has failed. So this particular pull request was adding the compromised package. And so the first thing that will happen is that the cooldown check will fail because this was a very recent package. And once the cooldown period is done, the check will pass normally. But because we had identified it as compromised and added it to our compromised packages list, this check also failed the compromised packages check. And so this basically prevents, developers from merging packages which are very new or which have been compromised. The other thing that I can cover in terms of these cooldown uh, policies is that we have capabilities to create automated pull requests to address a bunch of misconfigurations. You can add hardened runner, you can pin actions to a full length commit SHA, you can pin image tags and so on. And one of them is to also update the dependabot configuration. And in here, you can set up the package managers and then also set up the cooldown period there, right? So we had discussed that Dependabot allows you to set up this cooldown period, but you have to then go and update each repository. So with this, you can set this configuration and it will automatically create pull requests in your repositories and set up the right Dependabot configuration so that the cooldown uh, configuration gets set there. And I think that was pretty much all uh, that I wanted to cover. Ashish, was there anything else?
No, I think I briefly covered AI package analyst, but I think other than that, we've covered everything else.
Okay, so now we can,
Yeah.
look at the questions.
Yeah, so I can go through them, and Varun, we both can try to
Mm.
answer. And if anyone has any comments, please feel free to share that in the chat area. So let's start with the Q&A section, and then I'll go through the chat section. So the first question is, do we anticipate more sleeper attacks within the broader supply chain as malicious actors are suspected of sitting on credentials they exfiltrated from the Shai Hulud incident? Bonus question: does the Shai Hulud incident tell us about the upcoming Dune 3 movie plot? And what lessons does that hold for our community? Messiah book. Discuss.
So if you want, I can take up the first question, which is, can we expect more? And I think the answer is that we are already seeing these, right? So we have already seen secondary uh, incidents happening, um, you know, with Team PCP, after the Trivi incident. And so you can definitely expect more, supply chain attacks to happen. And the attack pattern is the same, right? Where once you compromise a credential, then the attackers will try to use that to get access to more resources, whether it is a GitHub repository, or a cloud environment. And then once they get there, they can get more credentials. In fact, previously we have seen once they compromise a GitHub repository, you can, if you're using GitHub Actions, you can create a new workflow and exfiltrate credentials. So so then the attackers have a lot more credentials, and then certainly you can see the amount of effort they're putting in for each of these exploits. So they are doing it for a purpose, and they would obviously continue to do it for their benefit. So you can certainly expect more of these to happen.
And I can take a stab at the second question. So I've seen both Dune movies and I really like them. I haven't, read the books. And I was reading somewhere about Dune 3 plot, and as per that article, the big threat in Dune 3 would be shapelifters who look exactly like trusted people, and they wait patiently before they strike. And I guess that is the current state of the supply chain security because of all these previous supply chain attacks. A lot of credentials have been stolen, and attackers are sitting on a lot of elevated credentials, and they are patiently waiting to strike. So I can go to the next one. Are there any documented payloads that do not make a DNS lookup to the C2 server mentioned in the IOC section. We saw one incident of the payload being downloaded, but no network traffic that matches the IOCs. In other words, was there only one identified payload or multiple? So, as per our analysis, when we downloaded both compromised versions and, we did static analysis of the, compromised package along with, this malicious dependency that was published. And when we did runtime analysis, we only saw outbound calls to the domain and the IP that we have mentioned in our blog post. At least we are not aware that, uh, whether there was, any other variant of the payload.
But if you have more details, definitely share, and then we can investigate and update the blog.
Yeah. So next, why these two specific versions of Axios were targeted? Are these most used versions? So the answer is yes. So the 1 dot series is the current one and 0 dot series is the legacy one. So both of these, package versions were compromised to maximize the impact. Can go to the next one. In regard to hardening and prevention, my understanding is that applying a GitHub action policy limiting allowed external actions and workflows, as well as requiring actions to be pinned to the full length commit SHA would have mitigated this attack. I'm curious if this is an agreed upon approach and how many orgs are capable of adopting this policy. So I know Varun, you have partially answered this question. Do you want to add anything else?
And like I mentioned, this is not directly related to pinning of the actions. Now, let's say there is a GitHub action and it is a node action or whatever it does. And if uh, that was going to, like, there are a couple of options. It could anyways be fetching the latest version. It could anyways be doing like a npm install of the latest version of a given package. So even if you pin the action, that doesn't necessarily mean that everything within that action gets pinned. And like I mentioned, we did have a report of at least one GitHub action, and I think we should update our blog post where it did download the latest version. So pinning of the action is not going to help you, from that perspective. Plus, the npm install may not have happened in the GitHub action. Like, let's say you have your own script where you're doing, you have your own workflow where you're doing npm install. You have a package.json, but you don't have a log file. Then if it ran during that time, it would just pull the latest. So pinning of the GitHub action, wouldn't necessarily be like the only thing that would prevent this kind of an issue.
Yes, there is a relevant comment, so let me just cover that. Varun, regarding pinning GitHub actions, thank you for clarifying. I'm mixing this vulnerability attack with Trivi Team PCP attack, which was compromised through a GitHub action supply chain attack.
Yeah, yeah. And there, it definitely would have helped. But even there, we have seen cases where Dependabot had updated it to a pinned version, which was compromised. In some cases, developers had ended up using that pinned version because everybody just sees what is the latest and, takes the commit SHA from there. And, you know, but you also need to check whether that commit SHA is actually a valid one or is it an imposter commit. And then the same, thing applies that just because it is pinned to a commit SHA doesn't mean that the action itself doesn't, download things which are the latest versions. A lot of actions do download latest versions of tools.
So next question is, sometimes a package is new because it's a response to a CVE. What are your
Mm.
suggestions to accommodate this with cooldown policies?
Yeah, so, from uh, from our platform's perspective, when there is a CVE, we add it to an exemption list, and then it does not impact, the cooldown check. But this is definitely a valid issue. And, it is in fact a thing that you can imagine attackers may even use it in the future, where once you have a way that, if there's a high CVE, then people are going to quickly merge it and it's going to bypass the cooldown policies, that they may actually try to do that. So this is where, there is a conflict between trying to not use a package which is new versus trying to use it because it is fixing a vulnerability. And so ideally, whatever feature you are using, it should support an exclusion list and it should support a way for you to exempt certain package and package versions so that you can go ahead with merging them. But it is good to be just aware that there is a conflict here. And even if you're looking at a CVE, you should verify that it is not malicious before merging. Just because it is, addressing a CVE and there is urgency, doesn't mean that it should just be merged without any kind of validation.
Next, hi, on running npm install on my local device, Mac got infected as I can see plain crypto.js in node modules. To correct this, should I just run npm install again by deleting node modules? Would this remove the threat, right? Or any other tasks need to be performed?
Yeah,
So
I
I
think,
guess in this,
yeah,
go
go
ahead,
ahead,
go ahead.
Ashish.
I can start. So I think in this case, if the malicious package ran on your device, it's safe to assume that it's compromised. And in that case, you should basically rebuild the device. So you should figure out all the secrets and credentials that were available on your device when the package was installed, and then you should rebuild the device, because as we discussed, this was a two-step exploit, right? So in the second step, a remote access Trojan was downloaded from the C2 endpoint, and we still don't know the exact functionality of the rat. So to be on the safer side, we are recommending that you should rebuild your machine. Okay, next one is, we observed in our environment that uh, a Azure Kubernetes cluster had installed the malicious Axios version, but the firewall was able to block the malicious C2 domain. Can we assume that our environment is safe if firewall was able to block malicious C2 domain? I think uh, based on our analysis, if you are 100% confident that the domain was blocked, then you can, it's fair to assume that the exploit code did not run, because setup.js wasn't doing anything malicious on the machine. So it was basically downloading the second stage payload from the C2 domain, and if the second stage payload did not run on your machine, then based on our analysis, secrets weren't exfiltrated, or like the basically the exploit didn't execute, unless the rat was downloaded and executed. And I'm not sure, Varun, if you have a different take on it.
No, and so in addition, you might just want to figure out how did it get there in the first place, and was it, through something that got deployed, or was it something that, like, it may have happened that, it went through the release process, or it was some third party, you know, container image that was do. So it would be good to figure out, exactly what made that call, and fix, whatever needs to be fixed in terms of the repository, or the container image, because you obviously don't want this to continue to run in your environment. I'm assuming you would have already done it, but just wanted to mention it.
Well, I can go through the chat area and see if we have any unanswered questions there. So one question is, do we know who the threat actor was, or is it that, or is it, or is that still unknown? And then there's a comment, that where community member has shared an article where Google has attributed this to North Korea, and we have also seen this article that a bunch of research firms have attributed this attack to North Korea.
Then, Ashish, you had also shared the comment from the maintainer who had mentioned that he had fallen for this scheme where they try to collaborate with open source maintainers and then end up compromising their machine.
Yeah. Yeah, so if you look at the original GitHub issue, the maintainer, whose account was compromised, they actually mentioned, what had happened, and there is this you can literally say attack wave going on where uh, especially North Korean state actors, they pretend to collaborate with influential developers or developers who are maintainers of really popular projects, and as part of that, they typically ask developers to clone a GitHub repository and open it in VS Code, and then that repository actually has a malicious VS Code configuration that ends up compromising their machine. So the maintainer hasn't specified how exactly their creds were stolen, but they did mention that someone had reached out to them for a collaboration opportunity, and they think that that actually led to this compromise, which again we have seen, like I said, from North Korean state actors. Next, there are a bunch of questions about the recording. So we will actually upload the recording on YouTube, and we'll update the blog, as well as we'll probably share a follow up email as well with the link. Next, actually, the most of packages don't need post install scripts, so it can be disabled and just use it when necessary. I think Varun, you already answered this question. Has there been any formal analysis published yet regarding the logic within the second stage payloads while the initial delivery was documented quickly? I'm specifically looking for a technical deep dive into the ld.py execution flow or persistent mechanism in the Mac OS scripts. If anyone has a link to a repo or a write up, I would appreciate the lead. So, unfortunately, we could not get to this stage because by the time we tried to retrieve these payloads, the C2 server was it wasn't available. Next, have there been any investigation of which IP numbers were being used as C2 during the attack? There is the well-known 142.11.206.73 and GTIG have hinted at 23.254.167.216, seemingly hosting a similar C2 without citing any specific data about it receiving traffic. Does anyone know of others? Asking for a flow log scanning friend. So based on our analysis, we have only seen the C2 domain and the 142 IP address. Next, let me see. What methods are used by package managers to securely determine the age of a package? Can it be spoofed in any way?
That's a good question. I mean, the way our platform does it for the cooldown check is that we look at the information provided by the NPM registry. And, you know, um, that, as far as I understand, cannot be spoofed. And my, understanding is that the other package managers also would look at the same information, like, what is the release date for that particular package as per the registry. Now, I'm not sure how this would work if it is a private package and a private registry, but at least for the public registry, it does provide information about the release date.
Next, any information on uptime for the well-known C2 domain sfrclak.com, which had also mentioned a C2 staging pivot domain, C call
Mm.
nrwise.com. Any other C2 domains IPs linked to this C2 infrastructure? So at least I've not seen this Viz article, but it's an interesting one. So we'll investigate and we'll update our blog post with this additional indicator of compromise. So next is, do you think this could be a nation state attack possibly coming from Iran? So I think we've already discussed that question. And there is also a comment that the Google threat intel points to North Korea. Sorry if this was discussed. Sorry if this was discussed, but has there been any high level preventative steps that devs could have followed? Thank you. So we did cover a bunch of preventative steps, that you can follow to prevent, these supply chain attacks. And we'll share the recording on YouTube. I believe restarting your machine will stop the rat, but then like Achi is saying, everything is compromised, so you have to rotate everything. Yeah, that's correct. And the last one is, how did this happen when the head developer of Axios mentioned that he's using MFA on practically everything? So my understanding is that again, this based on the GitHub issue thread, even though they were using OIDC for publishing these npm packages, for one of the OIDC scenarios, somehow that workflow also had a long-term npm token, and this long-term npm token was stolen basically to publish these packages. So even though they may be using MFA everywhere, these packages were compromised because a long-term npm token was compromised.
It's also, I think, interesting to mention that their GitHub credential was also compromised. And in fact, the attacker was actively deleting issues that were being created in that repository. Like I think Ashish himself has created probably 20 issues because each time it was created, they would delete it. And so even though GitHub uses MFA, once the machine is compromised, let's say they have GHCLI, then you can steal that token. And then using that, you can access GitHub.
Yeah. And this is a very common, attack pattern that we have seen for, in previous supply chain attacks like Shai Hulud, for example. They were, specifically going after GHCLI token. And typically these GHCLI tokens are quite privileged. So, they almost give you admin, kind of access on the user account. Question: any evidence or suspicious that beside the rat, the C2 could have delivered other backdoor slash persistent? This is a great question because since the second stage payload was coming from the C2 server, we don't know what it could have returned, because we do know that the first stage payload, which is setup.js, was doing device fingerprinting, and it was collecting information about the environment it's running in, and then it was sending all these details to the C2 server. Now the C2 server could have like returned different rat variants depending upon what was being sent to it. So this is a great question. I mean, my take is that we don't know, and it is possible that there are multiple variants of rat, and it's difficult to figure that out because again this was behind the second stage payload was hosted on a remote server.
And then connecting this to an earlier question about future supply chain attacks, right? So one of the things that has happened in this one is just this whole profiling about exfiltrating information about the environment. And from an attacker's perspective, this is very important because then they can, whenever they do the next one, they can actually target specific environments in a different way. So, yeah, so that's just something to keep in mind.
Yeah. Next, could you clarify that this attack might also affect environments where log files are not a standard practice in SDLC? For example, Axios, and there is minimum version for package.json file, and not pinning exact versions in package.log.json file.
Yeah, and this is one of the very common scenarios that we see that if there's no log file and if you run, npm install, then it will just get whatever is latest that matches the constraint. So the constraint says, just get the latest for version one, then it'll just go get the latest and install it. And this is why a lot of the CI environments or the developer machines, if you do npm install, it would, and you don't have a log file, and if you did that during the time window when these compromised packages were there, it would just get them and install them. And other point is you may be using a log file, but in your CI, if you're using some build tool or some GitHub action, that doesn't do the log file. Then again, the same thing can happen.
Yeah. And this is why, you need to look at all stages of your software development and delivery pipeline. Because, for example, if you're looking for this specific package version in source code repository, and like you said, if you're not using a log file, you will not find it there. But when, let's say, that project was built on a developer machine or in a CI/CD, on a CI/CD runner, those environments may have been impacted. So this is when you need to investigate across your entire software development pipeline. Next, in the sandworm, npm worm hijacks, the threat actor put in a 48-hour time bomb with an additional
Mm.
per machine jitter of up to 48 hours. Since threat actors usually do a quick grab of wallet and other information, then they put in a time bomb. What do you suggest as a cooldown period? And there is all thing. The socket block actually described this functionality.
Yeah, I think in terms of the cooldown period, we have seen it being used anywhere from 1 day to 30 days, and it really depends on your risk appetite. In terms of the fact that it may have a time-based trigger, but then also it doesn't mean that that compromised package will not get detected by that time. So what is important is that how soon will it get detected that it has some malicious code in it. Um, so cooldown policy, like it really depends on uh, how quickly you want the new features that are being released versus how much of a security risk you want to take. But in general, we've seen it being used, from 1 day to 30 days.
Okay, I think with that we have covered all the questions. So
Okay.
thank you once again, everyone, for joining us for this webinar. This was quite insightful. And as a next step, we will upload the recording on YouTube and share a link in our blog post as well as in a follow up email.
Okay. Thank you.
Thank you.